Hi, I'm Souvik. Let me show you GradPilot's technical infrastructure. Our project follows a microservice approach with separate services for different functionalities. Let me walk you through our five main microservices. Login registration service running on port 8080. This handles all user authentication, JWT token generation, and user profile management. Chatbot service on port 8081. This integrates with Google Gemini AI to provide intelligent assistance to students. And others are recommendation service, content, and user review service, and forum. Now, let me show you technologies we used. All our microservices are built with Spring Boot framework. We're using Java with Spring Security for authentication, Spring Data JPA for database operations, and Spring Web for REST APIs. We built our user interface with Next.js 14. Let me show you. We also use React 18. We're using TypeScript for TypeScript and Tailwind CSS for styling. The front end communicates with all backend services through REST APIs. We are using PostgreSQL as our main database. Everything is containerized using Docker. Our Docker Compose file orchestrates all services, database, and the front-end application. And this is the root directory of our project. All services communicate through well-defined REST APIs. We use GWT tokens for secure authentication across services.
Demonstrate our unit testing approach. Here is a test for our user authentication service. And there is mentor authentication service test, and these tests verify that when we call login method with valid credentials, it returns a proper JWT token. There are other services with unit testing also. Now I go to test. Okay, so this is our E2E testing, like E testing for our login flow, sign up flow. Navigates through our complete sign up flow, ensuring entering user credentials, selecting universities, and verifying successful registration. It tests. I go to Dockerization. Each microservice has their own Docker file, and we have our Docker compose.yml file. Our Docker images are hosted on Docker Hub for centralized distribution. Each service has its own repository: GradPilot frontend, GradPilot chatbot, a recommendation SOP service. Now I go to our large language model, our chatbot service, and we use Google Gemini. Integrate Google's Gemini LLM for intelligent features. Our chatbot service uses Gemini to provide personalized graduate school advice based on user profiles. That is, we can see we customize our prompt like this to make the chat responses personalized. Now we have a Cloudinary integration here in our forum service. So Cloudinary manages our media assets and file uploads. And these are our Docker containers.
For the configuration, we have used PostgreSQL as a database and we are managing it through Superbase. These database structure into several well-organized tables which ensures scalability and clarity. We have implemented a CI/CD pipeline using GitHub Actions. Here is the YAML file that defines the workflow. This pipeline builds and pushes Dockerized images with necessary testing, which are then pulled from a virtual machine. Here you can see the pulling part. Okay, so speaking of the virtual machine, we have used Microsoft Azure virtual machine with 4 GB RAM and 30 GB of storage. We can see the memory here, the size of the memory, and also the images we have put. For domain and deployment, we have configured Nginx and connected our domain via Nginx. And here you can see the Nginx configuration file. So back to our project. On the machine learning side, we experimented with multiple models to determine the best performing one for our university recommendation system. Here you can see 4 very popular models. and this is our training script, and here's the final model we are using. Also this is our predictor. Also for our handling the backend, we have created a email recommendation service file.